In the vast expanse of the universe, amongst swirling galaxies and twinkling stars, lies a microscopic world, a universe within ourselves. Here, particles dance to the rhythm of quantum mechanics, and one particle, so fundamental, so crucial to our understanding of the universe, that it has been dubbed the God particle, the Higgs boson. It holds the key to a fundamental question that has puzzled physicists for decades. Why do things have mass? The answer, physicists discovered, lies in the elusive Higgs boson and the strange field it generates. To understand the significance of the Higgs boson, we must first venture into the realm of particle physics, the world of quarks, leptons, and bosons. The standard model of particle physics, a triumph of 20th century science, is much like a grand symphony orchestra, with each particle representing a unique instrument. The standard model describes the fundamental building blocks of matter and the forces that govern their interactions. Like an orchestra that has sections for strings, woodwinds, and brass, the standard model classifies particles into different families. There are quarks, the constituents of protons and neutrons, leptons, such as electrons and neutrinos, and bosons, the force carriers that mediate interactions between particles. For instance, the electromagnetic force is carried by photons, while the weak force is carried by W and Z bosons. For decades, the standard model stood as a testament to the power of human ingenuity. It predicted the behavior of particles and forces with astonishing precision. However, at the heart of this elegant theory remained a fundamental mystery: the origin of mass. The standard model couldn't explain why particles had mass, nor could it predict what the masses of these particles should be. The concept of mass is intuitive to us. We experience it every day. It's harder to move a heavy object compared to a lighter one. But at the subatomic level, mass takes on a more profound meaning. It determines a particle's inertia, its resistance to a change in motion. It also dictates how strongly a particle interacts with the force of gravity. But where does this fundamental property come from? The answer to the mystery of mass doesn't lie within the particles themselves, but rather in the space between them. Imagine, if you will, a vast and invisible ocean. This ocean is the Higgs field, first proposed by Peter Higgs and other physicists. The Higgs field is unlike any other field we encounter in our everyday lives. It's a field of pure potential, and it's this potential that gives particles their mass. Particles move through and interact with the Higgs field. Picture the Higgs field as a thick cosmic molasses. Some particles, like photons, can pass through unimpeded. Other particles, like quarks and electrons, interact strongly with the Higgs field. Part 5. The Higgs boson, a ripple in the field. The existence of the Higgs field, while elegant and compelling, remained a theoretical construct for decades. To prove its existence, physicists needed to find its quantum mechanical counterpart, its associated particle, the Higgs boson. Just as a ripple in a pond signals the presence of water, the Higgs boson is a ripple, an excitation, in the Higgs field. When the Higgs field is sufficiently energized, it can create a Higgs boson, a fleeting particle that almost instantly decays into other particles. Detecting this elusive particle became the holy grail of particle physics, the key to unlocking the secrets of mass. Part 6. The elusive particle's prediction, a theoretical triumph. The theoretical prediction of the Higgs boson was a victory of human ingenuity, a testament to the power of mathematics in unraveling the mysteries of the universe. Peter Higgs, along with Robert Brute, Francois Englert, Gerald Guralnick, C.R. Hagen, and Tom Kibble, independently developed the theoretical framework for the Higgs mechanism in the 1960s. Their work, initially met with skepticism, gradually gained acceptance as physicists realized its profound implications for understanding the fundamental nature of mass. The Higgs boson became a cornerstone of the Standard Model, the missing piece of the puzzle that could explain why particles had mass and why the universe was the way it was. Part 7. The Large Hadron Collider, Chasing Shadows. However, finding the Higgs boson proved to be an experimental challenge of unprecedented scale. The energies required to create the Higgs boson were far beyond the reach of any existing particle accelerator. A new breed of machine was needed, capable of smashing protons together at nearly the speed of light. Enter the Large Hadron Collider, or LHC, a marvel of modern engineering, located at CERN, the European Organization for Nuclear Research, on the border of Switzerland and France. The LHC, a 27-kilometer ring of superconducting magnets buried deep underground, became the world's most powerful particle accelerator, capable of recreating conditions that existed a fraction of a second after the Big Bang. Part 8. Eureka! The Higgs boson has been found. On the 4th of July, 2012, the world of physics held its breath. After years of waiting, billions of dollars invested, and the tireless efforts of thousands of scientists, engineers, and technicians, the announcement came. The Higgs boson had been found. Two independent experiments at the LHC, ATLAS and CMS, had both detected a new particle with a mass of about 125 GeV-C2, which matched the predicted mass of the Higgs boson. The discovery was met with jubilation and a profound sense of accomplishment. The decades-long search was over, and a new chapter in our understanding of the universe had begun. Part 9. The Legacy of the God Particle. The discovery of the Higgs boson marked a truly momentous occasion in the history of physics. It confirmed the existence of the Higgs field, validated the Standard Model, and deepened our understanding of the fundamental nature of mass. But the story of the Higgs boson doesn't end there. This discovery has opened up new avenues of research, raising far more questions than it has answered. What are the properties of the Higgs boson? How does it interact with other particles? Are there other Higgs bosons, perhaps even more elusive than the one we've found? These questions are driving a new generation of experiments at the LHC and other accelerators around the world. Part 10. Unlocking the Universe's Secrets. The Higgs boson is much more than just a subatomic particle. It embodies human curiosity, ingenuity, and our relentless pursuit of knowledge. Its discovery has not only deepened our understanding of the universe we live in, but also inspired generations of young minds to explore the wonders of science. As we delve deeper into the subatomic realm, we have the potential to uncover even more mysteries, push the boundaries of our understanding, and discover that the cosmos is even more strange and wonderful than we could ever imagine. The Higgs boson, the God particle, has ushered in a new era of discovery, an era that promises to unlock the universe's secrets and reveal the fundamental nature of reality itself. The discovery of the Higgs boson has opened up new avenues in the field of particle physics. Scientists are now on the lookout for new particles and forces that could further our understanding of the universe. This chapter delves into the future possibilities of particle physics and the ongoing research that is pushing the boundaries of our knowledge. As we journey further into the unknown, it's clear that this adventure is far from over. The Large Hadron Collider continues to push the limits of what we know, searching for signs of dark matter, supersymmetry, and other exotic phenomena. Imagine a world where we can unify all the fundamental forces, where the secrets of dark energy are unraveled, and where quantum mechanics and general relativity are finally reconciled into a single, elegant theory of everything. The pursuit of knowledge propels us forward. New experiments and advanced technologies are being developed, paving the way for discoveries that will not only answer age-old questions, but also raise new ones. The future of particle physics is an exciting frontier, brimming with potential and promise. As we stand on the cusp of new scientific revolutions, one thing is certain: the universe still holds many secrets, and the adventure to unravel them has just begun. Join us on this incredible journey as we push the boundaries of human understanding and reach for the stars. Advancements in particle physics have had a profound impact on technology. Montage of various technological devices and scientific equipment. From medical imaging to data processing, technologies developed through particle physics research are finding applications in diverse fields. This chapter explores the technological innovations inspired by particle physics. Montage of various technological devices and scientific equipment. Particle accelerators, like the Large Hadron Collider, have not only advanced our understanding of the universe, but have also played a crucial role in treating cancer through advanced radiation therapy techniques. Video clip of a patient undergoing radiation therapy. Data processing techniques, developed to handle the massive amounts of data generated by particle physics experiments, have revolutionized fields like finance, telecommunications, and even artificial intelligence. Video clip of a data center. Medical imaging technologies, such as PET scans and MRI machines, owe their existence to principles discovered in particle physics research, enabling doctors to diagnose and treat diseases with unprecedented precision. Video clip of a doctor reviewing an MRI scan. Beyond healthcare, particle physics has also influenced materials science, leading to the development of new materials with properties previously thought impossible. Video clip of scientists working in a materials science laboratory. Innovations inspired by particle physics continue to shape our world, pushing the boundaries of what's possible and paving the way for future technological advancements. Video clip of a futuristic city skyline. Join us as we delve into the remarkable technologies born from the quest to understand the universe at its most fundamental level. The discovery of the Higgs boson was more than just a scientific endeavor. It was a testament to the power of global collaboration. Scientists from over 100 countries, transcending borders and cultures, united with a shared goal to unravel the mysteries of the universe. Clip 1. Scientists from different countries shaking hands and discussing at a table. Clip 2. International team working together at CERN. Clip 3. Video of the Large Hadron Collider in operation. Clip 4. Scientists monitoring data on computer screens. Clip 5. A montage of different national flags outside CERN. Clip 6. Interviews with diverse scientists explaining their roles. Clip 7. Footage of scientists celebrating the discovery of the Higgs boson. Clip 8. Video of international conferences and seminars. Clip 9. Behind-the-scenes footage of the experimental setup and teamwork. Clip 10. Panoramic view of CERN with scientists working together. This monumental achievement showcases what humanity can achieve when we come together, driven by curiosity and the pursuit of knowledge. The discovery of the Higgs boson is not just a victory for science, but a beacon of hope for future global collaboration in our quest to understand the universe. Behind the scientific achievements lie the stories of the people who made them possible. This chapter focuses on the human element, sharing the personal stories and experiences of the scientists who contributed to the discovery of the Higgs boson. Clip 1. A scientist looking proudly at the LHC. Clip 2. A young researcher working late into the night in the lab. Clip 3. A senior scientist explaining the significance of their work to a group of students. Clip 4. A diverse group of scientists celebrating a small victory in their research. Clip 5. A scientist video calling their family, sharing the news of a breakthrough. Clip 6. A researcher reflecting on their journey and the challenges they faced. Clip 7. A team of scientists engaged in intense brainstorming and collaboration. Clip 8. A close-up of a scientist's hands meticulously working with equipment. Clip 9. a scientist documenting their findings and sharing them with colleagues. Clip 10. A heartwarming moment of a scientist being congratulated by their peers. Their dedication, their sacrifices, and their relentless pursuit of knowledge truly made the discovery of the Higgs boson possible. These are the stories that remind us that science is not just about equations and experiments. It's about the people who dare to explore the unknown. The discovery of the Higgs boson, you see, it's not just about particle physics, you know. It has much broader implications. Clip 1. A wide shot of the night sky filled with stars, slowly panning across the universe. This chapter, it explores the philosophical and existential questions raised by the discovery and its impact on our understanding of the universe. Clip 2. A philosopher sits in an ancient library filled with old books, deep in thought. What does it mean, you know, to uncover a fundamental building block? How does it change our perception of our very existence? Clip 3. A montage of famous philosophers and scientists from Aristotle to Einstein. Throughout history, humanity has sought to understand the nature of the universe and our place within it. The Higgs boson, it adds a new chapter to this age-old quest, bridging the gap between the seen and the unseen. Clip 4. A visual representation of the Higgs field, with particles gaining mass as they move through it. It challenges us, you see, to think about the fabric of reality and the forces that shape our world. Clip 5. A scientist is giving a lecture to an engaged audience on the philosophical implications of the Higgs boson. Beyond the scientific community, this discovery resonates with anyone who has ever pondered the origins of the universe and the laws that govern it. Clip 6. A child is looking at the stars through a telescope, his eyes filled with wonder. It inspires a sense of wonder and curiosity, reminding us that there is still so much more to learn. Clip 7. A time-lapse of the sunrise over a serene landscape, symbolizing new beginnings and discoveries. The Higgs boson, you see, it's not just a particle. It is a gateway to deeper understanding, prompting us to ask profound questions about our very existence. Clip 8. A diverse group of people from different cultures and backgrounds, all looking up at the sky. It unites us, you see, in our shared quest for knowledge, transcending borders and cultures. Clip 9. A visual of interconnected neurons in the brain, symbolizing the connection between human thought and the universe. As we continue to explore, we find that the pursuit of answers is just as important as the answers themselves. Clip 10. A final shot of the Large Hadron Collider with the sun setting behind it, casting a golden glow. The discovery of the Higgs boson, it's just the beginning. It opens up a world of possibilities, inviting us to keep questioning, keep exploring, to keep reaching for the stars.